All right, so day one of second 9 weeks. You survived this far. Congratulations. We're a fourth of the way there. Um, this calendar is posted in Schoology under the red folder, useful links, something like that. So if you want to find it, that's probably the best thing to look at. Obviously, if you're at home, you know to look at the week at a glance to see what we're doing day by day. This week's a little bit different because we have PSAT on Wednesday. Seniors, you are working from home that day, all day, so that's most of you. And we won't be, I shouldn't be recording this, but it's a work day for you, put it that way. There's no new information since I only see some of the classes anyway. So if you've kept up and done what you need to do, it's a work day, is what it officially is. So you'll have a day to catch up on the 2 worksheets that you've got so far. Phrase it like that. It's not a free day, unless you've done everything you need to, and then you will have earned it. With the end of the 9 weeks, I thought this was kind of a funny, I don't know, maybe you won't think that's funny, but I thought it was funny. Considering report card grades are due today, most of your problems are caused by decisions you made. You guys know that. That doesn't really even apply to most of you. You guys have done a good job. So show that to your friends who've made poorer decisions than you have. Another interesting new thing about this 9 weeks is that we resume block days, kind of. So you have to just be paying real close attention as to what's going on. So this week is weird because most of you don't have to come to school on Wednesday. Next week is weird because we have a block day. The next 2 weeks we have a block day. So you're just going to have to pay attention to the school calendar and teachers to make sure you hit it if it's a block day or not. So ask if you ever have questions. It's posted on this. We'll try to keep you informed, but you gotta stay awake, stay alert. Otherwise, I guess it's not that big a deal. If you forget and you show up Wednesday, then first period will just go longer than normal, and that will remind you that you will have late arrival on Thursdays. Not this Thursday, though. Next Thursday. So we confused enough about the calendar? Seniors don't come this Wednesday. Next Thursday, everybody has block day, and then from then on, it's just kind of random whether we have a block day or not. So pay attention and be careful. First test isn't for 2.5 weeks or so we cover a lot of stuff in this unit. Circles, ellipses, hyperbolas, parabolas. Those are the 4 things that we'll do, and then we start doing stuff with those 4 things. This is something that is covered in Algebra 2, except that it was probably covered after spring break last year. Do y'all know? Do you remember? You don't even remember, and that's fine. I'll teach it from scratch, so it's no big deal. So I think you're supposed to have seen it, but I'll teach it as if you've never seen it before, and hopefully something comes back to you. Any questions on calendar, grades, syllabus, Schoology? Yes, ma'am?
What was Professional Growth Day?
Professional Growth Day down here, the 3rd, is we have to work, teachers have to work, you don't. You have off that day. It's election day, is why. So some of you can vote, I think. That's pretty cool. I don't know if that means, I guess that means you don't have to do online school that day. Yeah. It's the Tuesday election day. Would you rather it be the day after so you can stay up late watching the returns and see what happens? You're a political person? Yeah, I might be dragging the next day as well. You should care, but you probably shouldn't care enough to stay up too late. I've asked this before. How many of y'all are going to vote this time? Any of you voters in here? None of you are old enough to vote yet? Oh, man. Next time. Of course, next time is 4 years from now. So. All right, conic sections. We'll talk a few minutes big picture. Conic sections. There's four, actually there's more than four, but there's four conic sections that we'll talk about. Circle, ellipse, parabola, and hyperbola. Hyperbola. No, hyperbola. Don't pronounce it wrong. I know you've heard of a circle. You've probably heard of an ellipse. I know you've done parabolas. Have you done hyperbolas before? Yes? No? You don't know? Don't think so? Okay. Again, it's usually covered in Algebra 2, but given the circumstances of last year, maybe not. So these are shapes. Here's why it's called conic sections. Shapes formed by the intersection of a plane, geometry word, not like an airplane, right? Plane with a double cone. You may not have heard of a double cone before, but when I draw a picture of it, it'll make sense why it's called a double cone. So let's start with a double cone. It's a little bit of art class here, so you might want to draw your double cone in the same order I'm going to draw it. So draw sort of a flattened out circle, an ellipse at the top. That'll be the top of our cone. And then make a big X off the ends of it. And then we'll make another ellipse at the bottom, although I'm going to make the front of the ellipse a solid line and the back of the ellipse a dashed line because that's sort of behind. You can't really see that. Fancy. So that's your double cone. And really it goes on forever, but if you try to draw it going on forever, all you have is a X on your page. So the cone extends up forever and down forever. Probably the easiest intersection to see is to make a circle, because if we just take a slice of this cone, so here's my plane slicing that cone, it's going to make a circle in there. That's the shape we'll talk about today. So right now we're kind of doing an overview of conic sections, and then we'll spend 1 or 2 days on each of the four shapes. If you twist, or not twist, but if you rotate that plane, if you intersect it at an angle, something like that, well then your circle gets twisted, but not just twisted, it gets stretched out. And that's not a great ellipse, but maybe you get the idea. You get an ellipse. And it's hard to draw the other two, but I'll give it a go when we get to them. If you intersect your cone and your plane is parallel to one of the sides, so it kind of goes forever on the intersection. It's hard to visualize what that looks like, but that would be a parabola if it doesn't hit the other side. If you intersect your cone or your plane perfectly just like that, where it hits both sides, that makes a hyperbola. Since you don't know what a hyperbola is, that probably doesn't make much sense anyway right now. So we'll hold off trying to draw those because they're really hard to draw, especially since you're not really sure what they look like anyway. So today will be circles. And tomorrow will be ellipses. And then Wednesday is your day to kind of catch up on those and do the worksheet associated with those. And then after that, we'll come back and do parabolas and hyperbolas. So that's sort of the overview of Unit 4. Now let's talk specifically about circles. Our favorite form of circles is standard form because it's easy to pick off all the pieces of the things you need. X minus h squared plus y minus k squared equals r squared. Circles are pretty easy because there's not much to them. They have a center and they have a radius, and that's all you need to know about a circle. And so makes today's lesson quick and, I don't want to say easy, easier than the others for sure. So the center is at h and k. Be careful the sign changes, so you're maybe used to that. And if you're thinking about parent functions, if it's in there with x and it's x minus 3, it moves it to the right 3. Does that sound familiar? Okay, 1 yes, 1 no, and 18 not sure. Well, it's kind of the same thing. If you got x plus 2 in here, that would really be moving it to the left 2. And the y works the same way. If it's y minus 5, that would mean up 5. So that's why the minus sign's in there, because it goes backwards maybe from what you would think. And the radius would be r. So let's look at some examples. That's really all you need to know about them. Let's look at some examples to see how to work with them. Let's graph x minus 2 squared plus y plus 3 squared equals 9. So before we can graph it, or in order to graph it maybe, it'd be a better way to say this, I need to find its center and its radius, and then I'll be ready to go and graph it. So again, careful with the sign change thing. So x minus 2 means move it to the right 2, and y plus 3 means move it to the left 3, or it's not left, down 3, so 2, negative 3 would be the center. And r squared is 9, so r must be 3. On the worksheet today, you'll have graph paper provided, so you don't have to worry about making a super neat graph. I mean, your graph should be neat, but at least the graph paper will be provided. So over 2, down 3, there's my center. And you remember what radius means. That's how far away from the center you go. So I'm going to go 3 away from the center. 1, 2, 3, in every direction. Again, this will be much easier on a provided graph. So now you're just eyeballing it, doing the best you can. 1, 2, 3. 1, 2, 3. And so you'll have 4 points for your circle. I'm not grading your artistic ability, but if you make a diamond out of that, I'll take off a point. Like, it's a circle, so don't just play connect the dots. Try to make it a circle. Like, you don't need to get out a compass and trace it around, but again, don't just play connect the dots. Do your best to make a circle. That's not bad for my first circle of the year. I'll take that. And so that's the easiest kind of circle question. Just pick off the center, figure out the radius, and graph it. And again, graph a circle, not a diamond. Now we can also ask you, kind of some backward questions where we ask you to write the equation in standard form. So you're kind of used to this in math class by now. We teach it the forward way, and then we teach you how to, to test your understanding if you can work it backwards. So let's say we have a center at negative 5, 8 and a radius of 12. So it's the same thought process we just did. It's just using it a little bit in reverse. Right? We know what the standard form looks like. In fact, we could even put x and y in there. And so if I want to move left 5, what do I need in here with x? Plus 5 or minus 5? Plus 5. And if I want to go up 8, what do I need in there with y? Minus 8. And then the only thing that sometimes, people mess up the plus minus thing. Over here is r squared, so don't put 12 over there. 12 doesn't go there. 12 squared goes there. So 144. So that would give me a center at negative 5, positive 8, with a radius of 12. So pretty similar, just going backwards a little bit. And, when we get problems that are that easy, we try to start throwing wrinkles in there. We're like, everybody can handle that. Let's see if we can step it up just a little bit. So let's say congruent to x squared plus y squared equals 25, but translated up 5 and left 3. What's congruent mean? Same shape. And more than just same shape, same size. So it's a circle, but it's not any circle. It's a circle that has a radius of 5. So that's kind of what that clue is giving us, is that it has a radius of 5. So I know it's going to be 25 again on the outside, because that will give me a radius of 5. X and Y, up 5. I've intentionally put these in kind of the wrong order, because up 5, does that affect the X stuff or the Y stuff? The Y stuff. And so if we want to go up 5, how do I accomplish that? Minus 5 or plus 5? Minus 5. And then the left 3, that's an X thing. Left and right is X stuff. And it's kind of backwards, so that needs to be a plus 3 to move it to the left. Two more examples. Again, it's like all that stuff's pretty easy, so we need to try to give you something to challenge you a little bit. I know you appreciate that. So a center at 3, negative 1. Okay, well that part's easy. We know what that'll do. And we'll say it passes through negative 2, 2. So negative 1 passes through negative 2, 2. Okay, well, let's at least start writing down what we know, because part of this is easy. It gave us the center. So x minus 3 and y plus 1. But what we don't have is the radius. Well, let's draw a picture. Maybe that'll help. So there's 3, negative 1. and it passes through negative 2, 2, way over here. So I don't know, I don't really want to draw the whole circle, but the circle goes through that point. The radius is how far it is from the center to a point on the edge of the circle. So there's my radius. If only there was some way to figure out how long that is. Anybody?
Pythagorean theorem.
Yeah, Pythagorean theorem. So make a right triangle, and then just, as long as you've done this neatly, you can just kind of count. So some people use the distance formula, which is based on the Pythagorean theorem. I think it's easier to just think straight to the Pythagorean theorem. So over here was at 3. This was at negative 2. So that distance is 5. Again, you just have to be neat and careful. This point was down 1. This point was up 2. So that distance is 3. So r squared equals 3 squared plus 5 squared. So 9 plus 25 is 34. And here's the nice thing about this problem, or one nice thing, I guess, not a fun problem, but you get to the end here. You don't really need to know what r is, because what goes in the problem? R squared. And so I don't need to take the square root of this. I can stop short, because what I need in the problem is r squared. So if you do the extra step of finding what r is, that's fine. Then you have to square it again to get it back to r squared. So you can kind of just stop right there and say equals 34. Because what you need there is r squared, not r. Questions? One more. We're going to change this one from general form to standard form. Standard form is what we've been working with. Standard form is the form we like, because you can tell exactly what everything is. Standard form is the x minus h squared plus y minus k squared equals r squared. We like standard form because it's real easy to pick off the center and the radius, and you're good from there. General form, though, might look like this. X squared plus y squared plus 4x minus 6y minus 3 equals 0. That form is not helpful at all. Well, there are reasons to use that form, but none of them that we need. So we need to work on rearranging this to look like this. We need to change general form into standard form. So I think our first step should be, let's at least put the x's together and the y's together, and maybe get the 3 out of the way, because there needs to be some number over there. So let's rearrange a little bit. X squared plus 4x. I'm going to leave a little blank right in here. Plus y squared minus 6y equals 3. Okay, so I'm starting to look a little bit closer to standard form, and all I did was move things around a little bit. Do you remember a previous time when we left a hole of a space? You remember what we did there? What that was for? Completing the square. So we're going to complete the square on both of these so that we can factor it. So I need b over 2 for both of those things. So for this one, let's see, b is 4, 4 over 2 is 2. Oh, that's a B, not a 6. That one is a 6, sorry. A negative 6. So be careful, I'm not going to add 2, though I'm going to add 4, because you add b over 2 square. Half it, square it, add it. Half it, square it, add it. And of course, if you add it to one side, you got to add it to the other side, so be careful about that. This b is negative 6. Half of that would be negative 3. Square that, I get 9, so I'll do plus 9 on both sides. So complete the square. The key part of complete the square, we still got to do that. Half it, square it, add it. Got to do it twice. But now this factors, and it factors with that too, so I don't really even need to worry about thinking about what multiplies to 4 and adds to 4. It's always b over 2. And the same thought process with the y stuff. I can think what adds to 9 and adds to or multiplies to 9 and adds to negative 6, or I can just say, you know what, it's always that b over 2 term. And then 3 plus 4 plus 9, 7 plus 9 is 16. So there's a lot we do with circles. We can give you a standard form one and ask you to graph it. We can give you the information and ask you for the equation. We can give you some weird information and try to get you to give us the equation. And then lastly, we can give you one in general form and force you to do some old half it, square it, add it stuff. But kind of the easy part of it, and there's nothing more to do with it. Like you may remember when we solved quadratics and we had this step, that was like one of the major steps, but then there was like 14 other steps to go from there. Here, once we do that, we're done, because now we can see what the center is, what the radius is. We could graph it if we wanted to. All right, you're going to get a worksheet packet today. Don't panic, though, because the packet is for, I think, the entire unit. I think if Miss Morris, that was the plan. Yeah, we've got all the way to the review worksheet. So it's definitely a packet, but don't panic. 6 pages? It's 2.5 weeks worth of stuff. So don't worry about it. We'll take it one piece at a time. For you guys at home, there is a place where you can find this. I can do it this way. And they're all together. So you can print them all out at once, or you can print them out one at a time as you need them, however you want to do it. But today's assignment is Unit 4, Worksheet 1. It says circles and ellipses on it, which means we only need to do the first page of it, because the second page is ellipses. And so hopefully if you got to that, you'd think, wait a minute, we didn't do these. And you would be right. We did not. So job for today is page 1, just the very first page of this worksheet. You can see already that it's some graphing. That's an easy one. Graphing, but you got to change it into standard form on number 2 and 3 and 4. In fact, 3 and 4 look a little bit different. So let me hand you this, and then we'll do 3 and 4 together. All right, so if you're sitting at home, print this out, and we're going to do number 3. As you can see, it doesn't look right because there's a 3 on the x squared and y squared. But if we just divide everybody by 3, we can fix that. So x squared, dare I be adventurous and group the stuff at the same time I divide the stuff? And there's nothing to move over on that one. So divide everybody by 3 and rearrange. So the x is together, the y is together, the number by itself on the other side. So now it's more like number 2, like the last example we did. So, man, didn't give you much room to work. b over 2 would be negative 1. So plus 1 to both sides. And then b over 2 would be 4. So plus 16 to both sides. And then I'm out of room. I think I'm going to skip all the way down to below the graph to write the factored form, the standard form. So x minus 1 squared plus y plus 4 squared equals 17. So my center's at 1, negative 4. So over 1, down 4. A radius, remember you got to square root that piece, is the square root of 17. That's not a nice number, but what's it close to? If I want to graph, if I want to go square root of 17 away, how far is that? 4 and a little bit, right? The square root of 16 would be 4. So the square root of 17 would be 4 point something. That's a question mark right there, 4 point question mark. But for a graph, that's good enough, right? I'm not going to be able to tell the difference between 4.1 and 4.2 on a graph anyway. So I'm going to go up 4 and just a little bit, right 4 and a little bit, down 4 and a little bit, left 4 and a little bit. So my radius is 4 and a little bit. And then again, play connect the dots, but play them with the circle, not with the diamond. It's my second circle of the year. This one should be better than the first one. It's okay. And so you got a few more to try. They all match examples that we did. Again, today's assignment is just this page because the back of the page is ellipses, and then it kind of goes from there, but you don't even need to worry about the rest of them just yet.